Alright, so we've talked about congruent before. Now we're talking about congruent angles. The congruent symbol has little tilde above it. That's what that curvy line is called. Angles that have the same measure. So once again, we're repeating that congruent refers to figures, shapes, and objects. Angles are congruent. Their measures are equal. Equal is for numbers. If you have two right angles, they measure 90 degrees. 90 equals 90. But the two angles themselves are called congruent. They are congruent to each other. Okay, the protractor postulate. Protractor postulate says that the measure of an angle is equal to the absolute value of the difference of the real numbers on the protractor. So when we use the protractor to measure an angle, we set 0 on one side. So if we go back to this angle here, what we did was we set it so that one side was going through 0. So when we went up here to get this, between 48 and 49, we had, let's just say it's 48. So 48, 48 and a half. 48 minus 0 is 48. So the angle is 48. Now we could have, so this is what the protractor postulate is saying. I don't know why we would do this unless we only had part of a protractor because it was broken, but we could take this and say that that's 80 up here, and then this is 128. So 128 minus 80 is 48. So that's all it's saying. We wouldn't really use that. Or you could do it in reverse. You could do 80 minus 128, and you get negative 48, but that's why it said take the absolute value. So that's what the protractor postulate is telling us. But it doesn't seem like we would use that very often. Okay, the angle addition postulate. This one we will use. If P is in the interior of angle RST. So if we think about that, so we have angle RST, and S was in the middle, so we know that S is the vertex. So S, I'm going to put that on there first. Now, RST here. And so R and T can go on either side. It doesn't really matter. So R and T, or I could reverse those. So P is on the interior. So P is on the inside here. P is in the interior of RST. Then the measure of angle RSP, which we could create by connecting, by putting a ray through SP. So it says angle RSP plus angle PST equals the measure of angle RST, which should make sense. This angle plus this angle equals the total angle. So that's what the angle addition postulate says. Okay, plot the points. Then measure and classify the angles with vertex B. Okay. So, once again, plotting points. Points are in alphabetical order, X, Y. X is left and right, Y is up and down. So, -3, -1 is down here. So I'm going to plot that point. Now, it says label the points. When you put a point on there, you want to label it. Sometimes you might want to wait till you've drawn some stuff first because there's going to be some angles and stuff on here. So I'm going to pause it now and I'm going to plot these other 4 points. So, or maybe I'll plot 2, then come back, pause it again. So you should be plotting those other 4 points right now. That should be pretty basic. So go ahead and do that. So you can see I've plotted B and C here. I'm going to continue on with D. So D is 2, 1. So I'm going to go to the right 2 and up 1. And that's going to be point D. And then, and again, you can pause to plot E, pause. So E is 2, -2. Okay, then it says measure and classify the angles with vertex B. So what we're going to do is connect B to all of these other points. So and okay, so now we have some angles there. It says measure and classify the angles with vertex B. So we want to go in alphabetical order. The best letter for alphabetical order in this picture is A. So I want to, are there any angles that start with the letter A? And there are. So all the angles are going to have vertex B, so B is going to be in the middle of all of them. So then the next choice would be C. Alphabetically, that would be our best choice, A, B, C. Now, I don't need my protractor to measure that. That's a straight line, so that's 180 degrees, and that's called a straight angle. Classify means say what kind it is. So that's a straight angle. Alright, so the next angle that I can name would be AB, and D comes before E, so that's going to be ABD. Now I can think about this for a second. It looks like, so these two, this line and this ray, are perpendicular. I can tell because they have opposite reciprocal slopes. This has a slope of 1, the change in y is 1, the change in x is 1, and this one has a negative 1, because it's going down from left to right. So I know that this is 90 degrees. And then when I look at this, that is cutting that right in the middle. So 90 divided by 2 is 45. So I know that this is 45. So 90 plus 45, so maybe I'll put that down here, that's 90 degrees. And that's 45 degrees. And that's 45 degrees. Alright, so ABD, 90 plus 45, that's 135. That's bigger than 90, so that's obtuse, but less than 180. Alright, and there's one more angle I can name that starts with the letter A. ABE. ABE is 90 degrees, and that's a right angle. Now again, we're probably going to say this a lot, but eventually we're going to stop saying it. You should be pausing the video and trying to answer as much of this as possible. And then I would do one step at a time. So right now, pause the video and try to do the next step, and then play the video and see if you get the next step right. And then when you're done with that, pause it again, etc. Alright, so moving alphabetically, B would be the next letter, but B is not going to be, we're not going to start any of these angles with B because that's the vertex for all of them. So I'm going to move over to C. I'm going to ask myself, is there an angle C? And you probably could guess that there is because I already started to write it down. So CB. Now we're not going to say CBA because we already have CBA. CBA is right here, just by a different name. But that's the same angle, angle CBA. So I'm not going to use that one. So CBD would be the next choice. We already talked about the size of that. That's going to, the measure is going to be 45 degrees, and that is a cute little angle. Alright, so that's acute. Now, is there another C angle? Well, we could say angle CB and then E, angle CBE, which is also 90 degrees. And they might say, hey, we had a 90 degree. Yeah, but that was a different one. That was on this side. ABE is over here. CBE is over here. It's a different angle. And it's also right. Okay, pause, do the last. There's one left. Okay, and that's going to involve the letter D here. So DB and then E. And that's also 45. And so that's going to be acute. We get it a lot when kids do a graph like this. They forget to label the points. And we take a point off for that. So make sure you label those points. All right. Adjacent angles. Adjacent angles share a common side and vertex but have no common interior points. So that means they don't overlap at all. They don't overlap. So we have examples of that up here. So these two angles, these two angles are adjacent to each other because they share this side. There's no overlapping points. This is the interior of this angle. This is the interior of this angle. Okay? So adjacent angles are right next to each other, share a side, don't overlap. So sketch these adjacent angles. So as we look at it immediately, we can see that B is in the middle of both of those. So B is going to be the vertex. We also can see that they both have C in them. So that means that's the point in the middle. We put this on a test, and sometimes students miss this, and it's a little bit hard to understand because it's laid out for you right here. B is in the middle, so B is the vertex. C is in both angles. That means that C has to be in the middle. C has to be in the middle. It's in both angles. Now, all we have left is to put A and D on there. It doesn't really matter which side you put those on. So, as I look down here, I can see that one of my angles is 103 degrees. So, I'm going to factor that into my drawing. You don't really have to. We're not going to mark it wrong. When it says sketch, it doesn't have to be super accurate. But, like I said, I do see 103 on there, so I'm going to draw mine a little bit bigger than 90. So A and D are on the outside because there's only one of them, and it doesn't matter which one is which. So there's A and D. Alright, now there's two different ways we're going to ask this question. Sometimes we're going to give you the whole thing and one of these, and then you're going to have to subtract to give the other one. Sometimes, that's one case. The second case is we will give you the two smaller angles and you will have to add them together to get the big angle. So if you draw it on your paper, and it says to draw it, usually you can figure that out a little bit better. So the measure of angle ABD is the big angle out here, the whole thing. That's 103. So immediately I know I'm subtracting. Now, CBD, the measure of angle CBD, is 67. So that's going to be 67 degrees. And they're asking us to find ABC. So ABC is right here. So to do that, we're just going to subtract those two things. So we have a lot of subtraction in geometry, and we have a lot of borrowing, and so we want to be careful about that. So we're going to have to borrow off of here. That's going to make that 13. That's going to make that 6. We borrowed off here. That's going to change it to 9, and that's going to be 3. So the answer is 36, and because we're talking about the measure of an angle, we want to put degrees on there. If you don't put the degrees on there, we usually take a point off for that. Alright, so we finished up lesson 1.4, and now we have a couple review questions here. So this is the distributive property. It's on page 787. As needed. You do not have to do page 787. It's up to you. Okay? And if you do it, you don't have to turn it in to us. It's just for you. If you know that you need more practice, you should do, and you should mostly just do the odds because you can check them. And we showed you where to check them in the modules. It says answers to the odds. Okay, so R means review question number 1. So distributive property is when we're multiplying one thing by more than one thing. So we're multiplying this times both of these things. Now most students are pretty good at the distributive property. So we're going to multiply that times both of those. So we have a negative 5x times x. That's going to be negative 5x squared. And then this times this is going to be 35x. Now, this is the type of thing where you could have, as soon as you saw this page, you could have paused the video and you could have tried to do this problem since it's review. We should be able to handle that fairly easily. Okay, and so now would be a good time to pause. I would come back and check each problem as we go. So this is a little bit awkward that's on the back end here, so we want to make sure that we distribute this way. We can tell it's multiplication there. And so that's going to be negative 4b minus 8. Now down here, this is here because we see a common mistake here. We see students take 7 minus 5. That's wrong. Okay, you should be using the order of operations. And the order of operations says we multiply before we subtract. So we should be multiplying, and we should be multiplying this whole thing, negative 5, times both of these things. So we're going to have 7, and we have negative 5 times 2x, that's negative 10x. And we have negative 5 times positive 3, that's going to be negative 15. Now we're going to combine like terms, so we're going to have negative 10x, and so we're going to have 15 minus 7, which is 8, but the 15 is, the absolute value of the 15 is larger than this, so we're going to keep the sign there. One way you can think about that is you have 15 negatives and 7 positives. So 7 of the negatives are going to cancel out 7 of the positives, and that'll leave us with 8 negatives. Okay. This is off of a old high school test that students used to have to take to get a high school diploma. So the year 2010 is divisible by 3. How many years from 2010 will the year be divisible by 9? So let's see. One way, so your divisibility rules by 3 is if the digits add up to 3, you can divide it by 3. So 2 plus 0 plus 1 plus 0 adds up to 3, and since 3 is divisible by 3, then 2010 is divisible by 3. So the 9 divisibility rule is pretty similar to the 3 divisibility rule. If you can add up the digits and it's divisible by 9, then the number is divisible by 9. So here, that's just 3. 3 is not divisible by 9. So if we think about it, we want to get that to be 9. So if we add 6 to that, so 2016, then that would be divisible by 9. We can check that to make sure. So 2016 divided by 9, that's 2, subtract, bring that down, that's 2 again, that's 3, bring that down, and that's 4. So it goes in evenly. And you want to be careful here. It's a little bit of a trick question. So some students would say, oh, 2016 is the answer. But a lot of times you want to go back and read the question one more time before you put your final answer. It says how many years from 2010? So that would be 6 years later. All right. Now, formulas. This is on page 802. So if you need to work a little bit with these, look on page 802, do a couple of the odds if you need to. It's optional. Okay, so solve for r. That means we want to get r by itself. So there's a couple ways we could do that. When we have a fraction, one way to get rid of a fraction is to multiply by the reciprocal. So we could multiply both sides by 3/4 right away. Or we could multiply both sides by 3 first if we want to go slower. It's up to you. So that could be your first step. Now if you understood what I said about multiplying by the reciprocal, then you can just do that right away. That's fine. So I'm trying to get r by itself. I'm trying to get rid of this stuff. So I'm going to divide both sides by 4 pi. Okay, so those are going to cancel. And now you can see there's a 3/4 that I was talking about before. And then the final step would be to take, this is r cubed. So if it was r squared, we would take the square root. Since it's cubed, we're going to take the cube root. So we're going to take the cube root of both sides. So that is going to look like this. Okay, so we're going to get r equals, now this is a little bit complicated over here. You're going to go over stuff like this in Algebra 2. I think we do an example kind of like this a little bit later. But we don't really like that 4 pi down there. So in Algebra 2, you're going to do something to adjust that. But for now, we're just going to leave it like that. Okay. Now I have this one highlighted because this has shown up on some of our tests before. So you want to be very careful about how that you make sure you know how to do this problem. If you think you know how to do it, pause the video and see what you can do. If you have no idea, watch me do it, and then you may want to come back and try it again later. We do have the notes posted online, so you can always bring the notes up online in the modules and open it up to page 15, and then just get a blank sheet of paper out and try the problem again, since you know it's going to be on a test. So I'm trying to get A by itself. So the first thing I'm going to notice is I probably don't want this 5 over here. So I'm going to add 5 to both sides. So we're going to have y plus 5 equals ax squared plus ax. Now I'm trying to get a by itself. I only want one a. So what we're going to do is we're going to factor an a out of here, kind of the opposite of the distributive property. So somebody distributed that a and they weren't supposed to, so we need to take it back out. When you say pass that a back up. So we're going to factor out an a. So that's going to leave us with x squared plus x. And then if you just think about that for a moment, we could redistribute the a, multiply it by both of those, and we would get that. And we're almost done. We're trying to get a by itself. Right now, a is being multiplied by this, so we're going to divide both sides by that. Dividing is the inverse operation of multiplying, and it's going to eliminate that. So our final answer is going to be a is y plus 5 over x squared plus x. Now, you could also factor an x out of there. So your denominator could also be x times x plus 1, similar to how we factored out the a. Either one of those would be fine right now. In Algebra 2, mostly we would go ahead and factor that. Alright, so good job. Let us know if you have any questions. Really need more feedback from you about what you're having trouble with. Some of the assignments that have been turned in, we can see that there are some problems. So make sure in class that you're asking about those. I know everybody's getting the notebooks now. Almost everybody has one, and some of you had trouble finding the textbook. But we really need to get caught up, some of us. So let us know what we can do to help you. All right.